Hey guys, so till now we have seen free vibration. So we have seen free vibration chapter, and today we are going to start a new chapter that is forced vibration. So in free vibration, we have seen first that is undamped vibration, and then we have seen damped vibration. So here we are going to here now we are going to see forced vibration but only damped vibration. So what was the difference between free and forced? We'll see. So as the name suggests, free vibration and forced vibration. So the difference between both the vibration is that in free vibration there is no external excitation, sorry, there is no external force acting on the vibration. So suppose this was the case for free damped vibration, it is having a mass m, a spring of stiffness k, and a damper of damping coefficient c. Now in the forced vibration, the difference will be that now we are applying force, that is f0 sine omega t. We are applying force f0 sine omega t. Here we are applying this SHM, that is simple harmonic motion. So that due to which we are applying a force of having magnitude f0 and nature of sine omega t. Here we can take cos omega t also, any we can take sine or cos, but as it is follows SHM, we need to take either sine or cos to create a vibration that is of simple harmonic motion nature. So now what will be the difference in the equations? So we'll use same free body diagram. So if we apply the Newton's law to this if we apply the Newton's law to this free body diagram, so according to Newton's law, what will the formula? So formula will be that inertia force is equal to sum of external forces. So what are the external forces acting on this body? So if I want to write the external forces, so it will be, so f0 sine omega t in downward direction, then kx spring force in upward direction, and cx dot, that is damping force in upward direction. So these are the external forces. So external forces will be equal to, if I am taking upward as negative and downward as positive, then I am left with minus kx minus cx dot plus f0 sine omega t. So these are all the forces acting on this body. So now according to Newton, each and every force will be balanced with some or the other force. So that force we are taking it as inertia force. So that is mx double dot. So this is an inertia force. So now if I bring all the x terms on the left, so I will get mx double dot plus kx, sorry, let me write cx dot plus kx equal to f0 sine omega t. So now as you can see that what is the difference between the free and forced vibration in the form of equation. So in the form of equation, we got here the same equation, but here in the free vibration this term used to be 0, but now this term is not 0 here, and there is a force which is acting. So this is the difference. Now if this term was 0, then in that case the answer was only that is complementary function. But as this term is not 0, so the answer will be complementary function plus particular integral. So that is CF plus PI. So as we have already found how we can find CF, so this is not a necessary important. So we'll just focus on the PI. So how we can find the particular integral, that is PI. So to find this PI, that is particular integral, what we can do. So we have to, so we can use the similar approach for CF. So first, the first thing is that we will convert this equation to auxiliary equation. So what does it mean? So that I'm saying that let d by dt is equal to capital D. So therefore d square by dt square will be equal to d square. So as we know that x dot is dx by dt, x double dot is d square x by dt square. So we will use here m. First let's divide whole equation by m. So we'll get d square x plus c by m dx plus kx is equal to f0 by m sine omega t. Now here the x is common, so I will take x as a common. So let me take x common, x, x, x. So I am left with d square plus c by m d plus, sorry, so plus k, so plus k into x is equal to f0 by m sine omega t. Now if I make x as a subject, so I will get the value of x pi, that is particular integral. So I will make x as a subject, so I will get x pi is equal to f0 by m sine omega t divided by d square by c by m d plus, sorry, k by m here, so plus k by m. So this is the value of xpi. Now see, all the terms are having some meaning. That is f0 is force, mass, c, but d is just an operator. It is d by dt. So we need to remove d from this equation to obtain the value of xpi, because it's an operator and it doesn't have a physical meaning. So how we can remove the operator? So if we want to remove the operator, now we will apply our d. So what will the value of d square? So if I take, suppose x, suppose our x solution is, suppose anything, suppose it is, suppose sine a sine omega t. So I'm taking the this f0 sine omega t as a sine omega t, suppose. So what will be the x dot? So x dot will be a cos omega t into omega, and x double dot will be equal to a sine omega t into omega square, but with a minus sign. So what I will get is that x double dot I can write as d square x also. So I can write as d square x. So that is equal to minus omega square, and instead of a sine omega t I can write x. So x gets cancelled. So I left with d square is equal to minus omega square. So instead of d square I can write as minus omega square. So that only I will write here. So xpi will be equal to, so xpi will be equal to f0 by m sine omega t divided by minus omega square. Now I'm taking k by m on the left, so that is k by m minus omega square, plus why I've taken on the left, because in this term there is no d, and now in this term I'm replacing by minus omega square, so this term are free from the operator, so I've just merged into a bracket. So plus c by m d. Now there is a d left still, so we need to remove. So how we can remove? If this d converts into square, so we can remove it. So how we can convert this into square? So if I bring this d on the upper side, then so I will just multiply this denominator with the conjugate. if I multiply with this denominator with the conjugate, so I can replace the d. So what I will do is just multiply it by conjugate. It is f0 by m sine omega t divided by k by m minus omega square plus c by m d into k by m minus omega square minus c by m into d. So this is a plus b, a minus b. So if there are two brackets a plus b, a minus b, we know that it will be a square minus b square. So that only, so if as I would multiply it in denominator, I have to multiply it in numerator also. So k by m minus omega square minus c by m into d. So what will be the value of xpi? So xpi will be equal to, so let's start with the denominator first. So it will be k by m minus omega square whole square a square minus c by m whole square and d square. So now instead of d square I can write minus omega square instead of d square. So that I will write. So instead of d square I will write minus, so minus minus plus omega square here. So now what I'm left with, so now I have to multiply these two terms. So here there is no problem, so I will just multiply this term. So I'm left with f0 by m sine omega t into k by m minus omega square. Okay, now if I multiply with this term, so what will happen to this term? So here there's an operator d. So when operator multiplies with the function, so we need to derivate this function. So what we're left with is that f0 by m, this is constant and this also is constant, that is c by m into d sine omega t. So what are the derivative of sine? So sine derivative will be cos, so that is cos omega t, and also there and omega will come out, that is omega. So now I will just rearrange this term. So if you can see that f0 by m sine omega t into k by m minus omega square. So this is written as same it is. Now here I am writing with a minus sign. So that is f0 by m cos omega t into c omega by m divided by same k minus m whole square and c omega m. So I will just write here. So k by m minus omega square whole square plus c omega by m whole square. So as you can see that here the below term is this and the c omega by m is this. So this two terms and this two terms are similar. So therefore now as you can see here the terms that here it is something like sine something minus cos something. So if we can create sine alpha minus beta formula. So what is sine alpha plus or minus beta formula? As we know that sine alpha plus or minus beta formula is sine alpha cos beta plus or minus cos alpha sine beta. So if I take here f0 by m common outside, then we can convert this into sine alpha plus beta formula. So to achieve that, what we will take that this term as cos, that is we are taking it as k by m minus omega square is equal to z cos phi. We are taking as phi, and this term that is c omega by m is equal to z sine phi. Now what are the values of z and phi? So that we can achieve by trigonometric functions, that if we square this both times, and we can get the value of z, and if we divide this both, then we can get the value of phi. So what we will do that, by using trigonometric identity, the squaring both the term, so we will get that k by m minus omega square whole square plus c omega m whole square. So we will get, and similarly phi will be equal to tan inverse sine, that is c omega by k. It will be equal to c omega by k, sorry, yes, c omega by c omega and k minus m omega square. So here mm gets cancelled. So, or you can write in similar fashion also. So that is c omega by m. So this is sine and this is cos, that is k m minus omega square. So if you take LCM, so you will get this. So this is the value of z and phi. So what is our goal? To convert this equation into sine alpha plus beta to make it simpler. So the value of x pi I, so particular integral, our x pi I value of particular integral will be equal to f0 by m is constant. So I will write just f0 by m as constant, and in this also there will be a constant, it is z, that is both common. So that is f0 by m z, and now this term will be sine omega t cos alpha cos phi minus cos omega t sin phi. So this is the formula of alpha minus beta, that is omega t minus phi. So here I can directly write sine omega t minus phi. So this is sine omega t minus phi. This is the value of x pi I divided by, what is divided by? So that is k by m minus omega square. Now what is this? So this we have written it as, so this is nothing but z cos phi, and this is z sin phi. So if you square, so we'll get z square cos square phi plus z square sin square phi. So if you take z square as common, so you will get simple, there is sin square plus cos square, it is 1. So that will be this term, this whole term. So as you can see, if you take square of the z, so you will get this term similar. So it will be divided by z square. So here the z will get cancelled, so you are left with f0 by m z. So that is, so our xpi is equal to f0 by m sine omega t minus phi divided by z. You can write it as anything like z. Now if I want to make this equation more convenient, so let me put the value of z. So that is xpi is equal to f0 by m sine omega t minus phi. And what is the value of z? So z value, here it is shown that under root k by m whole square of c by m. So let me write this value, that is under root k by m minus omega square whole square plus c omega by m, that is c omega by m whole square. Now let me take the LCM of m and let's take cancel out m. So we are left with f0 sine omega t minus phi divided by under root. So here it will be k minus m omega square and whole square. Okay, so this is in under root, so divided by here m square. So m square I am taking as common m. So plus c omega whole square. So here also m square, so here both m square is common, so I'm taking 1 upon, if I take outside the under root, so m square will become m, and here the f0 by m it was, so here 1 upon m, so m gets cancelled, so we are left with this equation only. So now what is this? So this k minus m omega square uh, plus c omega. Now uh, as we know that was the natural frequency formula, so natural frequency formula is under root that is under root k by m, under root k by m. So this is the formula of natural frequency. Now here we have k and here we have m. Okay, now if I want to convert this into k by m, so here directly we could have converted into omega n, we could have written here it as omega n square. But now what we'll do, that let's divide the whole equation by k, let's divide this whole equation by n, let's take k outside. So what we are left with, so xpi is equal to f0 by k. So k we are taking from the denominator as common, so I have already written. So here k is square and root both, so it can come out as a k only. So here, so it will be 1 minus omega square divided by k by m, so that we can write it as omega n square. So plus c omega by k whole square, so this is also a whole square. So xpi will be equal to f0 by k sine omega t minus phi divided by, it will be written as under root 1 minus omega square upon omega n square. Now omega n square, so what is this ratio? So there is ratio of two frequencies. So here the ratio of force frequency to the natural frequency, the ratio we will call it as frequency ratio r. So that is frequency ratio r, so we'll call it as frequency ratio. So this ratio we will call it as r square, because they are both are square, so this is 1 upon 1 minus r square whole square plus, now here here it is c omega by k. So here also we need to we need omega n, so how we can get it? So what is c? So c is nothing but it is damping coefficient. So what is the formula for zeta? That is damping factor, so that is c by cc. So instead of c we can write that is as zeta cc, so we can write it as zeta cc. So instead of c, so what will be the c omega by k will be? So c omega by k will be zeta cc by k into omega. Now we know that what is omega n. So omega n is also written as cc by 2m, that is cc by 2m. So instead of cc I can write it as, so I can write it as omega n 2m. So I can write it as omega n 2m. So I can write here zeta omega n into 2m into omega into 2m divided by k. Now what is k by m? So k by m is omega n square. So here zeta omega n omega into 2, so I can write this omega n square. So k by m is also omega n square, so as here I have mentioned. So omega n and omega n square will get cancelled, so I am left with here 2 zeta omega divided by omega n. Now what is omega divided by omega n? So that is frequency ratio r, so that will be 2 zeta r. So instead of this whole equation c omega by k, I can write directly as 2 zeta r. So that will be 2 zeta r whole square. It will be 2 zeta r whole square. So our final equation for particular integral will be x pi, that is f0 by k sine omega t minus phi divided by 1 minus r square plus 2 zeta r whole square. So this is the final xpi equation, and this 1 upon this denominator term is called magnification factor. So it is called magnification factor. So xpi is equal to, I can write it as f0 by k sine omega t minus phi into m so this whole term 1 upon is called magnification factor. And now what is f0 by k? So as we know that f0 is equal to kx0. So that is f0 is equal to kx0, or we can write it as x0. So f0 by k will be x0. So we can also write xpi is equal to mx0 sine omega t minus phi. So this is our final equation. So this is our final equation for particular integral. So in the next lecture we'll see some vector representation and a magnification factor in detail. So thank you very much.